If you're not familiar with Josh Ingram's large laser machine for cutting carpets, here it is. It's 4 by 2 meters, and it was designed not only to cut carpets, but also wood, plastic, millboard, and anything else that will cut with the CO2 laser, as well as carpets. If you look at the end there, you'll see we've got some underlay. Cuts perfectly as well. This 4 meter by 2 meter machine was all hand built from pieces by Josh himself. And we can digitize any 2D object up to 4 meters by 2 meters, the size of the bed, to within an accuracy of about 0.2 of a millimeter. So we replace the cutting head with a red LED pointer. The red dot that you can see on the camera here is much bigger than what it is in reality. One of the biggest problems that we've had in doing that is driving the machine round efficiently at both slow speed and high speed has been these membrane keys. Even though I'm pressing this very gently, I get big steps, and the only way that I can get small steps is to reset the speed on here to get the precision control of that red dot. Josh absolutely hates these membrane keys. He has produced his own version of this part of the keyboard, collecting the coordinates of that red dot and transferring them onto a light burn screen. This keyboard, with its membrane keys, Josh calls them blobs. They are not very sensitive at all. If we have a large job, where as you can see the pointer is now, red dot pointer is right over there, Josh has to lean over the machine, over this keyboard, to see where the dot is. So it's very difficult to come back here and fiddle around with this keyboard when he's leaning over there. Although there is a remote control for controlling things, this does not do the job any better than these blobs. What we're now going to show you is a serious improvement that Josh has designed himself to make this machine a lot more sensitive to digitizing and getting the information quickly from here to the Lightburn program. What we've got here is a Mark 1 prototype to prove that we can get all the control and speed that we need on these buttons here, which are the same buttons as these. These keys are very, very sensitive. Even though this is in continuous mode on the Ruida controller and we can get fast speed, we can also, without doing anything other than lightly pressing the button, we can get very, very small motions. This is a brand new project, and what you see here is a prototype version of the keyboard that we can see works perfectly. Using this keyboard here, this door panel would take around about an hour for Josh to digitize. Using this keyboard, we've reduced that time to round about 10 or 15 minutes.
On this one, all in continuous.
So Josh has put 4 points on that hole and just a single reference point on all the other holes along the edge. Josh has managed to collect all the machine coordinates for that door card in around about 10 minutes. The next stage is to transfer that data as a DXF file to a CAD system where he joins all the circles up to make the outside shape and puts all the holes in to the correct positions. All we've got to do now is remove all the excess circles and save it as a DXF file, and then we can actually run it on the machine. This is Millboard. We're now going to cut the pattern that we've just seen. There's a special head that we use for cutting millboard, which is different to the head that we would normally use for cutting carpets. But as you can see, it still follows the contour of the bed, and if the material is a bit warped and bent, it isn't really a problem. You see the beam because it's invisible, but any carbon that's blown upwards is actually absorbing some of the energy of the beam as well. So there's quite a lot of carbon left on the edge, and that all gets cleaned up before the product is shipped.